In this video, we'll look at question 77 from the 2017 paper. In this question, we are supposed to solve an exponential equation. Make sure you are familiar with these log laws because I'm going to use them throughout without further notice. This is the product law and the exponent law. So when I was solving this equation, I did it in a completely different way. But later I found out that there is a very standard way of doing this at A-level, and it's taught that way across the UK, and it has been so for years and years. So I'll first show you the standard solution, and then the alternative way, the way I would have solved it. So the standard way starts with a pretty cool substitution, y equals 3 to x, which we shall substitute into this equation. So that's for the first term here, so the 3 comes from 3 to first power, and the rest is 3 to 2x, which is the same as 3 to x, the whole thing squared. And this part I just copied. Now when we do the substitution, we get a quadratic equation. 3y squared minus 6y equals 0. Let me factorize this. 3y times y minus 2 equals 0. And we can immediately read off the solutions as y equals 0 and y equals 2. You'll recognize that y equals 0 can't be a solution because then x would be log of 0, and that's undefined. So 2 is the value we want to go for, and if we now write 2 for y in this initial substitution, that's 2 equals 3 to the x, and log both sides, and we get that x equals log base 3 of 2, which is the final answer, and it was B. So now for the alternative way, which might be a good way for you if you didn't spot the initial substitution. So we first add 6 times 3 to the x to both sides, and we notice that this term is 2 times 3 to the x. And obviously we're going to want to take the log, base 3, of this whole equation. So these two laws will come in handy because the first one will help us evaluate the left-hand side and the second one for this product. And as we see on the left-hand side, the exponent goes down, and the log of the product is sum of logs. And on this one, again, the exponent went down before log 3 of 3. And of course, log 3 of 3 equals 1, which simplifies our expressions. So there's one, another one, third one. And that gives us a nice algebraic equation, which we can solve. It's linear, so we just subtract 1's, 1x, and what we get is x equals log base 3 of 2, the same answer we got before. And option B in the exam.